What does a typical data integration architecture look like? Hi, I'm Bindu Kumar, and in this video, I'm going to take you through the architecture of a typical data integration project while explaining the different components that make up this architecture. We will also take a closer look at each of these components and see what is the role that they play in this overall data integration architecture. Hi everyone. So in this session, we are going to discuss about data integration. So in my previous video, you must have seen the three styles of data integration. In this video, we are going to deep dive into the architecture of a typical data integration project. So let's get started. Again, a quick recap. What is data integration? So data integration is defined as a process where you converge data from different systems into a centralized location, right? So there are a lot of benefits that we get by doing a data integration project. So before we get into the architecture of data integration, let us look at a scenario where data integration does not exist. So we can purely understand what are the problems that we are trying to solve. So here is a picture where the top side of the slide has the upstream systems. So these are the systems that generate data. So for example, we have product lifecycle management, customer relationship management, and so on. So all these are softwares that are applications that generate data. And then at the bottom of the picture, you see applications that consume data. For example, customer loyalty, finance analytics, and so on. So these are systems that don't necessarily generate data. Instead, they consume data, right? So in any organization, it is normal to see these two categories of applications that generate data and applications that consume data. So for the applications that consume data, obviously they need to connect to these systems that generate the data. So here you can see customer loyalty is connected to the CRM system. It is also connected to the marketing management system, right? And over time, as you have more and more such downstream applications that need to consume the data, you will see them connecting multiple times. For example, the retail management or retail analytics is reading the data from the PLM system, right? And so is the financial analytics. It is also consuming the data from the PLM system. So over time, there are multiple systems that are reading data from the same system that generates the data. Right. So you can see a crisscross of lines between the systems that generate data and systems that consume data. Now, what are the problems with this? The problems are, first, you are connecting multiple times to the same system, maybe to read the same data, right? And every time you connect, you are duplicating your effort in terms of understanding the connectivity, setting up the authorization. Of course, it is taking up network bandwidth as well, right? So there are many things that are being duplicated when you connect to one system multiple times, right? So this is a picture in an organization where data integration is not realized. Now let's move on to the next slide. Now here we have put in a data integration project in place. So as you can see, the picture is a lot simplified. Not only simplified in terms of visualization, but in terms of the reality as well, in how the data flows, right? So now the data integration is one centralized layer where all the upstream systems or the systems that generate data, they push their data into a centralized location. Either they push or the data is pulled from the systems, right? So now the data integration project becomes the central hub from where all these other systems can pull in their information. Okay, so this also resembles a data lake in case you have seen it before. So data integration project tries to achieve the solution where you don't have to connect to multiple systems multiple times. So here you can see we are connecting to PLM just once. We are connecting to the order fulfillment only once. And in this one connection that we establish, we pull in all the data that is required and store it here once. And then that data can be reused multiple times by the different systems, right? Also on the systems that need to consume the data, for example, all these OLAP systems, they don't have to connect to different systems now. They just have to connect to this one central location and get the data that they need. So at a high level, this is the goal of every data integration project. Data integration project tries to become a single source of truth from where all the data that is needed can be consumed in a centralized fashion. Now let us look at some of the differences between an organization with a data integration project or without a data integration project. So the first characteristics that we are going to look at is effort redundancy. So without data integration, we know that all the downstream systems or systems that consume data need to connect to systems that generate data multiple times. So there is duplication of connectivity, duplication of know-how. Know-how refers to all the technicality that goes that is involved in terms of when it comes to connecting to a system. The process by which we collect data, data discovery, and of course data quality as well. With a data integration project, there is a one-time effort of all of this, right? Because you need to do that activity just once, and then that knowledge, that know-how can be shared with multiple downstream systems. Second characteristic is data discovery. So in data discovery, without a data integration project, data discovery is done in silos, meaning it is done in isolation from one project to the other. With a data integration project, your data discovery can be done once, hence it is centralized. There are multiple sources of truth without data integration. So let me give you an example. In a banking application or in a banking system, when you have to collect, let's say, the list of customers, there are different sources of truth. For example, the savings department will say that I have the list of customers. The loan department will say that I also have a list of customers, right? So which one do you consider as the master set? The answer is there is none, right? So this is the problem that you face when you do not have a data integration setup. But with a data integration setup, whenever you need a master list of customers, you just need to connect to that one central hub, one central platform from where you will get all the list of customers. Hence, with data integration, you now have a single source of truth for most of your data sets. Next is the velocity of development. So without data integration, the velocity of development is quite fast. Why? Because you are developing one system at a time, right? And you are probably dealing with, let's say, just 2 or 3 data sources from where you need to consume the data. So without a data integration project, the velocity of connecting to these different systems is quite fast. But with the data integration, it takes a little bit of time because you have to initially set up that data integration project, the centralized hub, and you're going to collect data from not 1, not 2, maybe a dozen systems. So, time wise, it is going to take a little bit longer, but it is very much worth the effort. Next is data enrichment. So data enrichment, refers to the process of you have some raw data, then what are the derived attributes, or what are the additional data that you can add to the existing data, right? So without data integration, it is often done in silos. So each application will enrich the data in their own terms, but this enriched data is then not shared with other systems, right? Hence it is done in silos, but with data integration, it is centralized. So any data enrichment that you do, it is then available to all your consumers. Impact analysis. What is the impact if, let's say, we were to remove a system from the feed, right? Again, it's very difficult to do it without data integration, but in a data integration, you have a centralized platform. It is very easy to see what are all the different systems that are impacted by this. Next is the enterprise data warehouse. So data warehouse refers to tools and techniques with which we achieve business intelligence. Okay, it's a very vast topic. I would probably do a separate session on it. But data warehouse, setting up a data warehouse is quite a challenging project, and without data integration, it becomes that much more difficult. But with the data integration, setting up a data warehouse or doing your dimensional modeling, all of that becomes a lot easier. Okay, so these are the pros and cons, or rather, these are the points that matter when you have a data integration or when you do not have a data integration. Any questions so far? I take the silence as a no. All right, so let's move on. Now let's look at a high level data integration architecture and try to understand what is the flow of data, right? What are the different stages and how they help. So we have the data source layer. Looking at this picture from the left side, the first thing that you see is a data source layer. Then you have something called as ETL. ETL is a process or a tool which helps in moving the data or copying the data from the data source layer into these different layers. You have a bronze, silver, and a gold level. I will do a deep dive of all of this in the coming slides. So this is where your data is copied. This is where your data is enriched and data quality is enhanced and so on. And finally, you have the data access layer. So this is the layer where you read the data. Okay. Now let's look at each of these components one by one and understand their significance in the data integration. So the first layer that we are going to look at is the data source layer. Okay. So you can see a miniature of the diagram that I showed you earlier in the previous slide. And we are right now looking at the data source layer. Right. So what is a data source layer? You see, data source layer is a virtual layer, meaning it does not have to exist as a one unified layer. Okay. Data source layer is a name that we give to all the different systems from which we consume the data. Okay. So I've taken the same systems from my previous slide. You have a PLM, you have a CRM, you have an order fulfillment, marketing, and so on. So all these are systems that generate data, right? Hence, they are under the data source layer. So these are systems that give us the data. And when it comes to connecting to these systems, there may be various interfaces. It may be through REST API, some kind of messaging queue, JDBC, SQL, GraphQL, and so on, right? So these are just some of the popular interfaces, but there could be more interfaces, like for example, SFTP, right? That's also an interface through which you can collect data. So data source layer is a logical layer where you keep all your source systems that give you the data. So when you build up your data integration architecture, it's very important to identify, okay, what are all my data sources, right? And then you keep them in the data source layer. Any questions so far? Now let's move on to the data ingestion layer or the ETL. So in the previous picture, you saw this ETL as a process, right? ETL, you can call it ETL or you can also call it data ingestion layer. right? So this is the layer where the data is consumed or the data is collected from the from these systems that generate the data, or from the data source layer. So in this picture you can see these are the systems on the left side. Then you have these different interfaces, right? From these interfaces we are using some kind of a ETL tool that will talk to these different systems through these various interfaces. All the data is collected and then it is kept in the data storage layer. So here usually people assume that okay, we are collecting the entire data. That may not be the case. Usually we only collect the data that is required for our analysis, right? So the data is collected and then it is stored. Now let's talk about this ETL. What is ETL? The moment somebody mentions the word ETL, the first thing that comes to our mind is ETL tools like Talent, Informatica, and so on. So these are tools that are built for ETL. But remember, ETL is not just a tool, it's a process. All right. So ETL is the name that is given to a process. Hence, how you achieve that process, right, is secondary. It can be done in various ways. So using ETL tool is just one of them. You can also write, let's say, stored procedures. You can write scripting, right? You can use materialized views in your database, right? So there are various ways of achieving that process. Okay. So always remember, ETL first and foremost is a process. How you do an ETL is the thing that comes later. So here I want to look at ETL as a process for the sake of this session. Okay. So we put up a process, a mechanism by which we connect to these different systems. All the data is collected and then we keep it in the data storage layer. Any questions? Now let's move on to the data storage layer, right? So data storage. So in the previous slide, we said that ETL is a mechanism by which we collect data and we store it, right? Where exactly is it stored? So that's where you have the data storage layer. So data storage layer refers to the layer where you have some mechanism for storing the data. So when we say storing the data, the first thing that comes to our mind is, let's say, a database, right? So database is built for storing data. But for the sake of data integration, right, we like to split up the storage into multiple layers. So here you can see the storage is split into a staging or a landing schema and then a reporting schema. So what exactly are these two? Let's look at the picture from the left side. Data that is collected from these different systems via an ETL process is pushed to something called as a staging or landing schema. Staging or landing schema is a schema or a database where you store the data as it is collected, right? You're not yet doing any kind of data enrichment, data cleaning, none of that is happening here. The data that you collect, you just store it as is. Hence, it is called a staging and a landing schema. Once this data is stored here, then through ETL or some other mechanism, you move the data to the reporting schema. So what's the difference between a staging and a reporting schema? In a reporting schema, your data is processed, your data is enriched, your data is standardized. You have business rules that are applied. So there are various rules and transformations that your data undergoes, and finally you have your reporting schema, right? So the difference between a staging and reporting schema is staging is data that you collect as is, which is also referred to as raw or unprocessed data, and reporting is the data that is modified to make it suitable for data access, right? So there are certain things that you're doing to the data to make it more easy for the user to consume it. Okay. So interestingly, You see the ETL being used here as well. Okay, so there is this misconception that ETL is only used when collecting data from the data source and pushing it to your centralized data storage, but that's not the case. Within the data storage, when you have to move data between different schemas or different levels, you still use an ETL tool. So here are the differences between the data in staging and reporting. So in staging, the type of data is raw or unprocessed data, but in reporting, it is processed data. When it comes to understanding data in staging, it is difficult. Why? Because it often reflects the data that is there in the source system, right? So unless you know about the source system, you will not understand the data in the staging area, right? In reporting, understanding the data is easier. Why? Because the data has been modeled as such. The objective of the reporting schema is to make the data more easy to understand. Formats. The data that you receive in staging often reflects the format of the upstream system. So your upstream system or the data sources might send you data in different formats. Some might send you data in a tabular format. Some might send you data in, let's say, semi-structured like a JSON or a CSV and so on, right? So staging data, it just collects the data as is, and hence the format is retained. So it's you are more likely to find many different formats of data in staging layer. But whereas in the reporting layer, all that is normalized into a single format. One format that is suitable for all your needs and something that is easy to understand. Doing data discovery is difficult because of all the other reasons, which is ease of understanding of data, the data format. Hence, data discovery is often difficult in the staging layer, but in reporting layer, it is easier. And when it comes to the data modeling, okay, data modeling refers to the process by which you model the data, you model the tables. In staging, you will see an entity relationship model, because entity relationship is the type of modeling used in systems that generate data, or OLTP systems or transactional systems. So in transactional systems, they follow an ER or entity relationship kind of data modeling. But when it comes to a data integration project or a data warehouse, it is typical to see a dimensional modeling. Okay, again, dimensional modeling is a very vast topic. I will probably cover it in a future session. So these are the differences between a staging and a reporting schema. But of late, there is another architecture style that is also being used within the data storage layer. So what exactly is that? So here we are talking about a bronze, silver, and a gold instead of a staging and a reporting, right? So what exactly is a bronze, silver, and gold, and how does it, how does it compare to a staging and reporting? So bronze, silver, and gold, they refer to the metals, right? And we know that as you go from the left to the right, the price of the metal increases as well, right? The cost of the metal increases. So how does it apply to data? You see, what this or why this is used for a presentation is, as you move from the left to the right, the quality of the data or the richness of the data also increases, right? That is why they started using these terms, bronze, silver, and gold. Okay. But function wise, it's very much similar to a staging and reporting schema. Let's look at here. So we have the characteristics, and then we have the different levels, bronze, silver, and gold. The type of data. So type of data is usually raw or unprocessed in bronze. So bronze is very much your staging layer. In silver, you have processed data. In gold, You have the same process data, but maybe it is modified into use case specific or aggregate data. So many times we create, let's say, tables that are needed for improved performance. All right. So that would fall into the gold level, whereas your base entities and relations, that would fall under the silver level. Ease of understanding: difficult, easy, and easy, right? Data formats: many, single, and single. So you'll see silver and gold share a lot of the same characteristics, right? Same goes with the data discovery. And in data modeling, we have the entity relationship in bronze, which is nothing but the staging. In silver and gold, we continue the dimensional modeling, right? But in gold, we might also use something called as OLAP cubes. This again is a very interesting concept. We will see it in a future session. But these are used to improve the experience by which you use the data, right? You consume and you analyze the data. So these are some of the things. So now going back to the slide, this is a picture that you'll often see even in data lakes to represent how the data quality or usability is improved as it moves through every layer. And then the user or the consumer of this data is free to connect to any different layer, right? So if somebody is looking for just aggregate data, they can connect to gold level. If there's somebody is looking at some fine grain data, they can connect to silver level. Or if somebody wants to process the unprocessed data, right, they want to look at the data as is, then they can connect to the bronze level. So data lakes offer all the three different levels. So the user is free to choose which ones they want to connect to. Okay, so these are just two different flavors of data storage. We have looked at staging and reporting, and we have also looked at the bronze, silver, and gold level. Any questions?
I have one question. So bronze level we call it as staging and gold level we call it as reporting level. So what is like silver level in general we call? What is this silver level? So
Okay. No, we don't call bronze as staging. What I meant to say is I wanted to just compare the previous slide to this slide. So I said that bronze is like your staging. Okay. Bronze is like your staging, and silver and gold is like reporting.
okay.
Okay. They are one and the same. It's just that different naming conventions. Right. So some people like to keep it simple. They will simply refer to it as staging and staging and reporting. Let me just go back. Yeah. So in earlier scenarios, people just used to refer it as staging and reporting schemas. Now within the reporting schemas, you will have your process data and you will also have aggregate data. All right. All of them is being clubbed into this reporting schema. But of late, people have started with these three levels: bronze, silver, and gold, to differentiate between the type of data. So they say that bronze is like your staging data, you have unprocessed data. In the silver level, you have data that is processed and modeled. And in gold level, you have the same data as in silver, but you also have aggregate data. Okay, so you can see there is not much difference. It is just difference in terms of how you want to refer to it.
Okay, got it.
Okay, any more questions? Okay, let's move on to the last layer within a data integration project, which is a data access layer. Right. So data access layer, as the name says, this is the layer where you access the data, right? So now you have, put in all the hard work of collecting the data, taking it through the different levels, and finally data is available. Now you have to make this data available to your end users. Now your end users might access the data through various interfaces, right? So here I have mentioned some of them. Data analyst might write SQL. Somebody might use Kafka streams. They might use GraphQL, JDBC drivers, or maybe even REST APIs. So a properly built data integration project must be able to support few of these interfaces, if not all of these interfaces, right? And then you also have users who use some tools, like for example Tableau, which is a dashboarding tool, or some kind of a data mining tool, which will directly connect to your data storage layer to one of these levels and start reading the data. So the data access layer refers to the layer from where you expose the data. Now there are many things that need to be handled here. First is your data storage must be such that it supports all these different kind of interfaces, or at least the few that you have decided for your project, right? And second, it also depends on the maturity of your users. Like, are your users or your consumers mature enough to use GraphQL? Do they know how Kafka streams work, and so on, right? So it's a multi-factor decision that needs to be taken, where you need to look at the data storage, you need to look at the users, you need to look at your infrastructure, and then you need to come up with a data access layer. Also, the authorization happens here, right? So many times the data that you collect is confidential. You don't want to share all the data with everyone, right? So what you do, you put in data access rules. For example, only the people from the HR department can access HR related information, right? Only people from the sales department can look at the sales information, and no one else, and so on. So all those kind of rules are usually enforced in the data access layer. So data access layer is not only about the interfaces, but it's also about authentication, authorization, role level security, and so on. Any questions so far? Now to conclude everything that we have discussed so far, the first point, a DI setup or a data integration setup is critical for unified view of data. Once again, I stress upon it. Whenever you have to think about a solution, think what happens if the solution is not there, right? What is the problem that we are trying to solve? So without a data integration, it becomes chaotic, right? All the downstream systems have to connect to many different systems to collect the data, right? Because there is no unified view. And many times there are multiple source of truth, right? There is no single source of truth, right? So it's very chaotic without a data integration project in place. But with a data integration project in place, people are now getting a unified view of data, one central hub from where you can consume all the data. You can also think about this, like your experience in a supermarket. You go to a supermarket or even to a mall, right? It represents one place from where you can get all the different things that you need for your shopping, right? It may be clothes, it may be food, it may be whatnot, right? It may be dress and shoes and so on, right? So you get into this one place and you have the best of everything in one central location. So which, helps you avoid traveling to 10 different shops spread across the city, correct? Similarly, data integration achieves a similar thing. It collects all the data that you need in a centralized location. So you just connect to the central hub, and from there you have all the data you need. You don't have to connect to multiple systems. Okay. Second bullet point is, a data integration project should be process driven and not technology driven. And this is very important. So what do I mean by this? Should be process driven. Process driven meaning from day one, when once you've decided that you have to set up a data integration, the entire data integration project including the technology that you select, everything, it should be driven by the process, by the requirement, and not by technology. Okay, it's not like okay, I have a database, I want to use Postgres as my data storage. Let me now start my data integration, push the data into Postgres. Okay, that should not be the scenario. The scenario must be, or the decision must be, okay, I have these different systems I need to collect to connect to, and these different systems give me data in different formats. Like some of them give JSON, they CSV, tabular data. Now, what is the best storage from where to where I can keep this? Is it Postgres? Is it Hadoop? Is it MongoDB? Is it something else? Right? So you see the difference. You don't start with the technology, you start with the process, and then you identify what is the right technology for you. Okay, so the entire data integration project should be process driven and not technology driven. The third bullet point, usability should be the first outcome. This is the most important thing. Now, I've been in projects where people worry about the performance, people worry about which tool are we using? Are we using the latest and greatest tool, and so on? So that doesn't matter. What matters is, irrespective of the technology you use, right? Is it being usable, right? You might use something like Postgres, which is 20 years old, right? It's as a database, it's existed for close to 2 decades now, right? But it doesn't make it old, right? It makes it very mature. It makes it easy for you to find developers who can work on Postgres, correct? Whereas look at something like NoSQL, like MongoDB or Hadoop. These are the new kids on the block, right? It sounds very interesting to use them, exciting as well, but does it solve the problem, right? So it's not so much about the technology, it's much about the usability of it. Whether you use Postgres or Mongo or Hadoop, are your consumers able to easily access the data, right? So usability should be the first outcome of your data integration project, and it should be maintained as well. It's not that you find it usable in the first version and the latest in the following versions you don't care about it, or in the following releases, right? That should not be the case. Usability should always be the output of your data integration project. The fourth bullet point is, an effective data integration requires expertise across multiple disciplines. So as you have seen, data integration is not just one tool or one technology. You need expertise across multiple things, right? And that takes you to the last bullet point. So an architect who's working on a data integration project, he or she must possess the skills across all these different tools and technologies. Starting with the database. Database is the most critical part of your entire data integration project, because that is where you need to store the data. So a DI architect must understand how a database works. What exactly is a database? What is SQL? The data architect must also know about data modeling. Data modeling, which I will cover in future topics, is also a very, very critical part of any data related project. Okay, so there are various types of data modelings. We will learn about relationship modeling, dimensional modeling, right? So a data integration architect must be able to decide what kind of data modeling to use. Okay. The third point, OLTP versus OLAP. OLTP versus OLAP again is something that I will discuss in future sessions in detail. But here, if I have to say, OLTP are systems that generate data, and OLAP are systems that consume data. And there is a big difference between how the two systems work. Not only how they work, but how they are designed as well. There is a big difference. I've often seen people who have spent a lot of time working on OLTP systems are suddenly given the responsibility of building an OLAP system, and those systems fail miserably, right? So a DI architect should know what are the differences, why they are different, and also be able to decide when to use what. Okay. Then the data access methods. So DI architect should be familiar with the different methods or interfaces such as REST API, GraphQL, Kafka Streams, SQL, JDBC, and so on, right? Because if you are aware of these interfaces, then you can build your data access layer accordingly. Finally, the last bullet point is SQL versus NoSQL, right? So whether to go with a relational database that supports SQL or to go with a NoSQL, right? So all these are things that a data architect should know. Of course, this is a very, very small and high level list. There are a lot of other things that an architect should possess. But these are the things at a high level. If the architect knows this, then it will result in an effective data integration project. Right. So with this, we have come to the end of the session. Any questions so far?
Hi, I have one question regarding that bronze, silver, and gold. Can you give me real-time experience example of this? Why do we use exactly a bronze, silver, and gold, and why not a staging because even the reporting layer does have this gold level of data. Like we do the entire transformation and everything and store it.
Sure. Yeah. So in order to explain that, let me just go back to the staging and reporting. Okay. Traditionally, when we have built a data integration project, we have stored the data across staging and reporting schema, and we have always told our data access layer, right? So here this represents the tools and interfaces and users who need the data. So we have always told them that, look, you should only connect to reporting schema. Why? Because reporting schema represents the process data. You should not connect to staging schema, because this represents the unprocessed data, and I cannot guarantee the data quality here, right? So we have always told the users that please do not connect to staging, only consume from the reporting. So there it made a lot of sense just to keep an let's say how do I say it, allowed area and not allowed area, right? So we are saying, okay, you are allowed into reporting but not allowed into staging. So it's a binary option. Yes here, no here, right? But as we step into the age of data lakes, we step into the age of data science and so on, where users don't want to limit themselves only to the process data. Sometimes they also want to be able to connect to unprocessed data as well. Maybe because they want to measure the data quality. Maybe the analysis they want to do has more to do with unprocessed data than with processed data. In such cases, we don't want to put a barrier saying, okay, you can only connect to gold or silver level, right? Instead, we are saying that, look, data is now categorized into 3 levels: bronze, silver, and gold. Bronze is where you have the most raw unprocessed data. Silver is where you have slightly processed data, right? So processed data with rules and cleaning and everything. Gold is where you have processed data, but then you also have data prepared for a specific use case. For example, let's say there are 10 entity tables here. Okay, there are a couple of tables here, but then there is one particular use case that requires combining all this data or joining all those 10 tables, and it's becoming a performance problem. So what we do is we will pre-aggregate the tables, right? We'll pre-join the tables, pre-aggregate them, and make it available as a single table. And that single table is considered to be a gold level table. So the gold level represents data that is use case specific or aggregated. Okay, so now we can tell the users that you can connect to the silver level if you want the process data, but if you're looking for a very specific use case, right, then you can connect to the gold level, and there you will have the data that is pre-aggregate. So did I answer your question?
Yeah. Thank you so much.
Yeah. Okay, so to summarize, there is not much difference between a staging and a reporting. Okay, staging and a reporting. So in staging and reporting, staging was strictly off limits to the user. We will say that don't go in there, right? Because the data that you access there, you will not be able to make sense out of it, right? But now there are users who are willing to take that risk. They take that ownership of that. Okay, let me find out what the data is all about. I will do the data discovery myself, right? So for such people, we like to think of the architecture as these three levels: bronze, silver, and gold. Now they are free to choose which level they want to connect to and consume the data. Okay, thank you for the question. Thank you for watching this video. Did you like the content? Well, there are a lot more videos coming in this series. So the only way that you will get to know when I upload them is to subscribe and hit the bell icon. So please do that. And also, if you like the content, do share it with your friends and colleagues. And if you have any comment or feedback, just leave it in the comments section. Thank you once again, and see you in the next video.